In this video, 5.3 part 2, we're going to actually go through and work with the quadratic formula and talk about some of the different issues you run into when you're using the quadratic formula, when you have square roots or imaginaries or things like that. So first off, let's just do some examples with that. And so number 6, underneath where we left off, solving the quadratic formula. So here is an equation, that's a quadratic equation. And in order to solve or use the quadratic formula, there's a couple of things that have to happen. Number 1, this must be 0. If it's not 0, then make it be 0. So if it said like equals 5, you would have to subtract 5 from both sides, but it has to be 0 because this is based on x is going to be by itself. Okay, and the standard form is ax squared plus bx plus c equals 0. If that would have been like equals 3, then that doesn't work the same way. The quadratic formula would not be the same. So you have to make it 0. So that's number 1. Number 2, you need to identify your a, b, and c. So your coefficients, a, b, and c. So a is 1 here, b is -4, and c is +4. Make sure you get the signs right. Then you're going to take your quadratic formula and all you're going to do is just plug in. So negative b, that means negative b plus or minus the square root. Now b squared is going to be whatever b is and you're going to square it. So it's always going to be positive because -4 to the second power is -4 times -4. That's what you're doing. -4 times a times c, and then this is all over 2 times a. So I want you to write that out. I don't want to just see on your homework that you just have an answer magically appear. I know you're going to do some calculator work, but there should be some on the paper because you're simplifying radicals and you're, adding things and stuff like that. So I want to see on your paper what you've got. So x equals +4 plus or minus the square root of 16 minus 16 over 2. So that's 4 plus or minus the square root of 0 over 2. Well, what's the square root of 0? It's just 0. So that means 4 plus or minus 0 over 2. Well, 4 plus 0 is 4, and 4 minus 0 is 4. So you just have 4 over 2, which is 2. So your solution is just 2. Now, question. I thought, didn't we say that all quadratics have 2 solutions? And they do. This one has 2 as a solution, but it's actually what we call a solution twice. So it's a solution of multiplicity 2. So that just means it's a solution twice because it has to have 2 solutions. And so again, when we get into the next unit and talk about graphs and things, we'll talk about what does that mean. But if you have a solution and it's based on something like that, you're only going to see one answer there, but it's a multiplicity 2. So you don't really have to say multiplicity 2 or anything. You can just say that x is equal to 2. But that's what that means. Okay, let's do another one. So again, we see that this is 0, a is -2, b is 5, c is -8. Make sure you've got the signs correct. So for these first few, I'm having you identify the a, b, and c. Now as you get more practice, you won't need to do that as much. But if you're getting the signs wrong, then that's definitely the first thing you want to check. So you're going to have -b, so -5 plus or minus the square root of b squared, -4 times a times c. Write that out. And then over 2 times a. The majority of this part of it should be done with no calculator because you know all your square numbers, and so that's not really an issue. Sometimes you'll get bigger numbers under the radical, but you can deal with that. You can use a calculator if you need to, but try to do it without. Now you've got -4 times -2 is +8, and then times -8. That's going to be -64 over -4. So I've got -5 plus or minus. Now 25 minus 64, that's going to be a negative number. And so you know you're going to have imaginary solutions here. So you know you're going to be dealing with i's. And so one other thing we're going to have to be dealing with is how to simplify a fraction that looks like this. So that's one reason I want you to make sure that you're going through all these examples with me. Now 39 is 3 times 13, which I can't do anything to simplify that, but the I does come out. So we're going to put a little I right there and then square root 39 over -4. So that's your solution, but it's not actually simplified, okay, because of the negative. So a couple of ways to look at this. This is really two terms, so you could look at it like this, which actually this helps to kind of explain what we're going to do. If we look at it like that, then this right there is positive 5 over 4. The positive or negative, so if it's positive over a negative, it's going to be negative, and if it's negative over a negative, it's going to be positive. So really what you have, you still have a plus or minus situation. Minus plus, it doesn't matter which one you say first. So the way that we say that is x is equal to 5 plus or minus I square root 39 over positive 4. That's the simplified version of that. And so when you're simplifying something like that, if you have these negatives right there, you can look at it as it's canceling with those by just flipping that, because it's got to work with both terms on your fraction. So that's how you would simplify that one. And you can just write your answer like that. You don't need to write it in set notation necessarily. Just kind of depending on the directions. It does not say in the directions that you have to write these in set notation, so we don't necessarily have to, but if you did, you would just add on that. Okay, let's go to the next one. Number 8. So again, 0 is there, negative 5. And you might think, well, isn't 0 always there? It's not always there. So we're going to have plenty of experiences where it's not always that. So go ahead and pause the video, work through this, just make sure you understand, and then let's meet back at the end so you can see how to simplify your solutions. Okay, I've got the first few steps here. So I plugged in my A, B, and C. I had 25 written down there for C, but I figured out that I had done that wrong. So anyway, I wrote out all the steps. And so something like this is what I would expect to see on your homework, that you've simplified those steps through there. So if you didn't come up with the same thing at this step, then you want to pause and go back and see what you did wrong. Okay, at this point, I'm going to take the square root of 676, which is 26. Now, that's not one you have memorized, so yeah, you're putting that in your calculator and checking, but anyway, that's what you've got. Now, remember what we've talked about before. This is two separate things, so we're going to talk about negative 14 plus 26 over 10 and negative 14 minus 26 over 10. So negative 14 plus 26 is going to be 12 over 10, which is 6/5. And negative 14 minus 26 is negative 40 over 10, which is negative 4. So my solutions are 6/5 and negative 4. And so writing that in set notation. Sometimes you see it just, I've seen it just as you get higher in math. Sometimes we kind of take a little shortcut or skip on the set notation, write it like that. I'm not going to have a problem if you want to just do that. Okay, number 9, notice first off that that's not a 0. So the first thing I need to do before you do anything else, because if you don't do this first, everything's going to go wrong. You cannot say that C is negative 4. If you say C is negative 4, everything's going to be wrong. You're not going to have the right answers. It's just going to go badly. So the first thing you need to do is you need to move that to the other side. So we're going to have 8x squared minus 8x plus 4 equals 0. Now you can identify your A, B, and C. Do not identify them until you've got it equal to 0. So go ahead and pause, take it through this one. You're going to have imaginary solutions. I'll just give you that heads up right there, and then just make sure that you've got it simplified at the end. Okay, I have written the first couple of steps here, so I put it in the quadratic formula so you can see how I have the negative b, and I have the negative 8 is squared right there, so it's b, whatever it is, squared is going to be positive. You'll notice that I'm taking away something bigger from something smaller, so 64 is a square number. So you'll notice that when that's bigger, you're going to end up with a negative under your radical. So that's what happened back in number 7 as well. You were having 25 take away 64. This one's 64 take away 128. So that is when that happens, when you have this negative. And so I've got 8 plus or minus the square root of negative 64. Now the square root of negative 64, the square root of 64 is 8, and the negative is going to come out as I. So you're going to write it like that. So this is what you have now to simplify that fraction. Remember, this is two separate ones, and so especially here at the beginning when you first are dealing with a lot of questions like this, you probably want to recognize this as two separate fractions. So that's 1/2 plus or minus 1/2 I, or I over 2. And so you can write that as 1 plus or minus I over 2. But you want to just make sure that you're not just canceling that. You would also have to cancel that. So you have to make sure you recognize that that's two different fractions, and that's why we cancel factors, not terms. So one thing I could do is I could say, well, I'm going to factor out an 8 from that, and I'll be left with 1 plus I over 2 times 8. Now the 8's cancel because they're factors. And so that's another way you could look at that. Okay, of course you got the 1 plus or minus. But anyway, that's another way you can look at that, but make sure you've got all that together. Now before we end this video and go on to the last part of this, let's look at number 10. It says, how can we tell if there will be no real solutions, one real solution, or two real solutions? So just looking back, if you look back at number 6, we had one real solution. And remember, I told you it was multiplicity 2. So that was 2, and it's a real number. And then in number 7 and number 9, we had 2 imaginary solutions. Okay, so 2 imaginary solutions. And that is also the same thing as saying 0 real solutions. Okay, so one thing about imaginary numbers, because quadratics have 2 solutions, and because of the way we have our quadratic formula, it's impossible to only have one imaginary number. If you're going to have an imaginary number, you have to have another one because there's a plus and a minus. And so it's either going to be 2 imaginary numbers or no imaginary numbers. You cannot have just one. You can have one real because it can be multiplicity of 2, but if you have 2 imaginary, you have no real or no real, or sorry, 2 imaginary and no real. So you can't have it. So I kind of jokingly say that imaginary numbers are like missionaries. They always travel in pairs. You cannot have just one. So how do we tell? So do you remember looking at number 6 again? Look at what you had. You had 4 plus or minus the square root of 16 minus 16 over 2. Then if you look at number 8, which also had 2 real, you had negative 14 plus or minus the square root of 676 over negative 10. So both of these are real, but this one only had 1 real solution, and this one had 2 real solutions. So what was the difference here? And then if you look at numbers 7 and 9, what did they have in common? So 7 and 9, we had negative 5 plus or minus the square root of negative 39 over 4. And number 9, we had 8 plus or minus the square root of negative 64 over 16. So what did they have in common? It's pretty easy to see that these both had in common that you're taking the square root of a negative number. So when you have 2 imaginary numbers or 0 real numbers, under your square root, your b squared minus 4ac, that's going to be smaller than 0. It's going to be a negative number. When you have something that is greater than or equal to 0, then you get real solutions. If it is equal to 0, then you get 1 real. So b squared minus 4ac would equal 0, whereas if you get 2 real, it's because b squared minus 4ac is greater than 0. So that number that's under your radical, that has a special name, and it's called the discriminant. Okay, the discriminant gives us the information. So b squared minus 4ac, that is the discriminant. And if it's greater than 0, then there's going to be 2 real solutions. If it's equal to 0, there's going to be 1 real solution. And I'm going to put in parentheses. You don't have to write this like when you're normally saying what your answers are, but I'm just going to write that so we know that we have multiplicity 2. If the discriminant is less than 0, then we have 2 imaginary solutions, which means no real solutions. Okay, so the quadratic formula, and we're going to see as we go on also that the different parts of the quadratic formula are very useful because they tell us things. And so the discriminant part, that tells us about the types of solutions that we have, whether they're real or imaginary. And so that's really useful to us. So if we were to ask, just tell me how many real solutions you have, I'm saying you don't need to solve these. Don't tell me what the solutions are. Just tell me how many real you're going to have. Are you going to have 1 real, 2 reals, or no reals? So all I have to do is use my discriminant. So first of all, make sure that that's a 0, and you're going to do b squared minus 4ac. So that's 16 minus 12. So that's 4. Because that's greater than 0, I'm going to have 2 real solutions. Number 12. I need to get everything on the same side. So first off, because you cannot use the quadratic formula or any part of it unless you've got that set equal to 0. So if I do b squared minus 4 times a times c, I'm going to have 64 minus 16 times 9. I don't even care what that is because I know it's bigger than 64, so I know I'm going to be taking away something bigger anyway. It is 144, but I'm going to have a negative number there, so I'm going to have two imaginary solutions. And then for number 13, again, get everything to the same side because it doesn't even matter if you don't have everything on the same side. So I'm going to have b squared minus 4 times a times c. So 36 minus 36, that's equal to 0. So I'm going to have one real solution. And so that tells us, whoops, not the 4, that tells us how many real solutions. For number 12, it would also be correct if you said 0 real solutions. So depending on how I ask the question, you would say either 0 real or 2 imaginary. So if I say how many imaginary numbers do you have, or solutions do you have, you would say 2. If I said how many real, you would say 0. Okay, go to the last video and we're going to actually put this into practice in some different situations. The main difficulty we run into in this is where you have to simplify your fractions with radicals and imaginaries and things like that. So that's where you really want to pay attention to what's happening in the rest of the lesson.